Ever wondered why the microscopic world doesn't play by the rules of the world we see around us? Welcome to the realm of quantum physics. Quantum physics, often referred to as quantum mechanics, is a branch of physics that deals with phenomena on a very small scale, such as molecules, atoms, and subatomic particles like electrons, protons, and photons. It's a world where the rules as we know them just don't seem to apply. In the everyday world, we're used to certain principles. An apple falls from a tree because of gravity. A car in motion stays in motion until an external force, like the brakes, brings it to a stop. This is the world of classical physics, a world that's predictable and intuitive. But once we venture into the realm of the very small, things get a little, well, weird. Quantum physics introduces us to a world where particles can exist in multiple places at the same time, where they can spin in two directions simultaneously, and where their properties are only defined when they are observed. Yes, you heard it right. A particle's state isn't determined until we decide to look at it. One key concept that sets quantum physics apart from classical physics is the dual nature of particles, also known as wave-particle duality. This idea suggests that particles can exhibit characteristics of both particles and waves. To put it in simpler terms, sometimes these tiny specks of matter behave like solid balls, and at other times, they behave like waves rippling on a pond. This fascinating and somewhat mind-boggling concept is a cornerstone of quantum physics. It challenges our understanding of the world around us and opens up a whole new realm of possibilities. So why is quantum physics significant? Well, it's more than just a curiosity. Quantum physics has led to the development of many technologies we use today, from the laser to the transistor, and it holds the promise for future technologies like quantum computing. So, buckle up and get ready to dive deep into the fascinating world of quantum physics. Imagine if you could be in two places at once. Sounds impossible, right? Not in the quantum world. In the realm of quantum physics, this seemingly impossible feat is an everyday occurrence. The principle that allows this mind-bending phenomenon to happen is known as quantum superposition. It's a concept that essentially states that a quantum particle can exist in multiple states simultaneously. Let's break that down. Picture a spinning coin. While it's in the air, you can't tell whether it's heads or tails. It's in a superposition of states, both heads and tails at the same time. It's only when the coin lands, the moment you observe it, that it takes on a definite state. This is exactly how particles behave in the quantum world. They exist in a superposition of all possible states until they are observed or measured. Then, like the coin, they collapse into one definite state. But what's even more mind-blowing is how these particles move from one state to another. This is where quantum leaps come into play. In the quantum world, particles don't travel from point A to point B. Instead, they leap from one state to another without traversing the space in between. It's as if you're at home one moment, and the next, you're suddenly at the supermarket, without any memory or experience of the journey in between. How does this happen? Well, that's one of the many mysteries that make quantum physics so fascinating and elusive. What we do know is that these leaps are instantaneous and random. They can't be predicted or controlled, only observed after they've happened. So, the next time you wish you could be in two places at once, remember, in the quantum universe, particles can be both here and there at the same time. What if we told you that the more precisely you know the speed of a quantum particle, the less you know about its location? Sounds like a riddle, doesn't it? But in fact, it's a fundamental principle of quantum physics, aptly known as Heisenberg's uncertainty principle. Let's dive a little deeper. This principle, named after the brilliant physicist Werner Heisenberg, essentially tells us that it's impossible to simultaneously measure both the position and velocity of a microscopic particle with absolute certainty. Now, you might be wondering why that is. To put it simply, the act of measuring a particle affects the particle itself. Imagine you're trying to take a picture of a buzzing bee with a high-speed camera. The faster the bee moves, the harder it is to get a clear shot of it. Now, replace the bee with a quantum particle and the camera with your measuring tool. The faster the particle moves, the blurrier its position becomes in your measurement. And if you try to get a clear shot of its position, its speed becomes uncertain. It's a bit like a cosmic game of hide and seek, where the particle is the elusive player that never gets caught. It's there, but not really there. It's moving, but you can't tell how fast. It's an enigma wrapped in a paradox tucked inside the complexities of quantum physics. In the macroscopic world, the world we live in, this seems absurd. If you track a car speeding down a highway, you can easily measure its speed and location. But in the quantum world, things don't play by our rules. This is where the uncertainty principle comes into play, challenging our understanding of reality and pushing the boundaries of what we consider to be possible. So, the next time you try to wrap your head around the complexities of the quantum world, remember Heisenberg's uncertainty principle. It's a reminder that in the realm of the tiny, the world as we know it gets turned on its head. Welcome to the world where certainty is a luxury we can't afford. Ever heard of spooky action at a distance? No, this is not a Halloween tale, but a real phenomenon in the quantum world. Let's dive into one of the most mind-boggling concepts in quantum physics: quantum entanglement. Quantum entanglement is a phenomenon where two particles become so intimately connected that the state of one particle instantaneously influences the state of the other, no matter how far apart they are. Picture it like a pair of dice. You roll them, and no matter how far apart they land, if one shows a 6, the other will always show a 1. They are entangled. But how do particles become entangled? Well, it can happen in several ways. Sometimes particles can become entangled when they are created at the same time or when they interact with each other. This interaction causes them to become linked and to maintain this connection, regardless of the distance that separates them. Now, the really strange part is that this happens instantaneously. This means that the moment you measure the state of one particle, you immediately know the state of the other. This is regardless of whether they are side by side or light years apart. It's as if the information between the two particles travels faster than the speed of light. But wait, doesn't that contradict Einstein's theory of relativity, which states that nothing can travel faster than light? Yes, it does seem to. But quantum entanglement doesn't violate any laws of physics because no real information is being sent or exchanged. It's just the way quantum particles are. This phenomenon has puzzled and fascinated physicists for decades. It is not only a fundamental aspect of quantum mechanics, but also a key to many future technologies like quantum computing and quantum cryptography. Quantum entanglement truly exemplifies the peculiarity of the quantum world, where the traditional laws of physics that govern our everyday world just don't apply. So, distance is just a concept when it comes to entangled particles. If you think your computer is fast, wait until you hear about quantum computers. What if we told you that there's a type of computer that could solve problems in seconds, which would take today's fastest supercomputers millions of years? Welcome to the mind-bending world of quantum computing. At the heart of this technology is the strange and wonderful world of quantum physics. Unlike classical computers that use bits as their smallest unit of data, quantum computers use quantum bits, or qubits. While a conventional bit can be in one of two states, 0 or 1, a qubit can be in both states at the same time, thanks to a quantum quirk called superposition. This means that a quantum computer can process a vast number of possibilities all at once. Imagine being able to read every book in a library at the same time, compared to reading them one by one. That's the kind of speed we're talking about. But that's not all. Quantum computers also harness another peculiar quantum phenomenon known as entanglement. When qubits become entangled, the state of one qubit will instantaneously affect the state of another, no matter the distance between them. This allows quantum computers to solve complex problems at an astonishingly fast pace. Now hold on to your hats, because this is where it gets really exciting. Quantum computing has the potential to revolutionize a multitude of fields. From creating new drugs and modeling complex chemical reactions to optimizing large systems like global supply chains, the potential applications are virtually limitless. Bear in mind, though, we're still in the early days of quantum computing. There are enormous technical challenges to overcome, but companies and researchers around the globe are racing to build practical, scalable quantum computers. Quantum computing could be the next big leap in technology, opening up unimaginable possibilities. Indeed, we're on the cusp of a quantum revolution that could redefine what's possible in the digital world. Buckle up, because the quantum future is going to be a wild ride. You may think quantum physics is just for scientists in laboratories, but it's much more prevalent in our daily lives than you might realize. Quantum physics, the science of the very small, is at the heart of many modern technologies. Let's take a little tour around some of the everyday items that owe their existence to the principles of quantum physics. First stop, your living room. Ever wonder how your flat-screen TV or computer monitor works so seamlessly? Thank quantum physics. These devices use liquid crystal displays or LED technologies, both of which rely on quantum mechanics. The science behind this is complex, but in simple terms, quantum mechanics makes it possible for these devices to emit different colors of light, allowing you to enjoy your favorite shows and websites. In the realm of medicine, quantum physics plays a significant role too. The magnetic resonance imaging or MRI scanners, used to create detailed images of the human body, function on the principles of quantum physics. It's the quantum properties of the atoms in your body that make these images possible. Now, let's talk about your phone. The semiconductors in your mobile device, which are essential for its operation, are a direct application of quantum physics. Without understanding the quantum behavior of electrons, we wouldn't have semiconductors, and without semiconductors, we wouldn't have modern electronics. Even the Global Positioning System, or GPS, which helps us navigate our world, owes its accuracy to quantum physics. The atomic clocks used in GPS satellites rely on the principles of quantum physics to keep accurate time, making sure you never lose your way. The list goes on and on. From lasers and solar cells to digital cameras and even the internet itself, quantum physics is the invisible force powering the modern world. And it's not just about technology. Quantum physics also helps us understand the universe, from the smallest particles to the biggest galaxies. From the screen you're watching this video on to the stars in the sky, quantum physics is everywhere. As we wrap up our journey into the quantum world, there's one thing we can say for sure. It's a place full of surprises. In the past quarter of an hour, we've delved into the mysterious and fascinating realm of quantum physics. We kicked off with the Quantum Conundrum, highlighting how our everyday logic fails to interpret the strange phenomena at the quantum level. We saw how particles can exist in multiple places at once, and how they don't have definite properties until measured. We then jumped into quantum leaps, where we explored the concept of quantum jumping, the idea that electrons can move from one energy level to another in an instant without passing through the space in between. The idea is mind-boggling, isn't it? But that's the beauty of the quantum world. Discussing Heisenberg's uncertainty principle, we learned that it is impossible to simultaneously know both the exact position and momentum of a particle. This principle, while seemingly absurd, is fundamental to our understanding of the quantum realm. Next, we tangled with quantum entanglement. This eerily beautiful concept describes how pairs or groups of particles can become linked, such that the state of one instantly affects the other, no matter how far apart they are. This spooky action at a distance, as Einstein famously called it, is yet another example of the quantum world defying our everyday intuition. The fifth stop on our journey was quantum computing. We discussed how quantum computers could revolutionize our world, solving problems that are currently beyond the reach of classical computers. In our last segment, we talked about the quantum impact, highlighting how quantum physics is not just an abstract theory, but has real-world implications, from the development of new technologies like quantum computers to our fundamental understanding of the universe. So next time you look at the world around you, remember there's a whole other universe playing by its own rules, right under our noses. Until next time, keep exploring the quantum world.